To be here. My name is Radek Grabowski. I work for WGI in the SU division under the umbrella of our geospatial division. Today we'll be talking about how evolving ACSE standards influence SU data collection and 3D utility mapping. A little bit about me. I am the National SU Production Manager for WGI. And I'm going to share my screen right now. And I've been doing this for about 23 years now. I started out of high school as a rodman in a survey outfit, actually in Europe. And when I moved to the States, I worked in surveying and started doing subsurface utility engineering probably 13 years ago. A little bit about the history of SU. I wanted to touch on that. I saw that I think we have 130 participants, which is awesome. Thank you everybody for joining. Early 1980s, two technologies emerged: pipe and cable locators and vacuum excavation trucks. In 1981, SU is founded by SODEEP in Virginia, and then following that, a couple years later, in 1984, Virginia DOT began using SU on their highway projects. In 1989, SU was first introduced at the first National Highway Utility Conference, and then late 80s and early 90s, Federal Highway Administration introduced SU to all the state departments of transportation. In the 1990s, East Coast DOTs started using SU more profusely, and in the early 20s, it spread nationally and internationally. And I know we've been talking all day pretty much about SU. I just want to kind of remind everyone, subsurface utility engineering is an engineering practice that has evolved considerably over the past few decades. The SU process combines civil engineering, surveying, and geophysics. It utilizes several processes and technologies, including records research, surveying, surface geophysics, and vacuum excavation. And as the new standards that will be ratified this year, 3820 ASE standards, the definition, the specialty practice of civil engineering's utility engineering branch that includes the investigation, analysis, judgment, and documentation of existing utility networks. There were quite a few case studies done about the benefits of SU. I'm just going to mention one. In 1999, the Federal Highway Association commissioned Purdue University to study the cost savings from 4 state DOTs that routinely utilize utility quality levels while producing contract drawings. Across 74 projects from Virginia, Ohio, Texas, North Carolina, Oregon, and Wyoming, and Puerto Rico were studied. The total construction costs of these roadway projects exceeded $1 billion. Some of the items that Purdue University analyzed was the cost items: utility relocation and cost, utility damage, emergency restoration, traffic delay, business impact, user service outage, environmental impact, legal and litigation costs, utility design. After the study was concluded, overall, it was determined that for every dollar spent on SU, you save an approximate $4.62, which is an astronomical figure if you take into account $1 billion worth of cost for a project. Since then, it has become an industry best practice. SU has been adopted as a best practice approach by various administrations, societies, municipalities, consultants, utility owners, DOTs. And some of the new definitions in the standards, some are updated. We're going to be talking about, we're going to be using these later on in the presentation, Eddie and I. I will be joined by Eddie Gayton from our Chicago office in a moment. One of the definitions that we'll be using is anchor point, which is a point on a utility feature or the ending point of a utility segment that serves as a beginning or ending utility segment. It could be point on the structure. It could be a quality level A point. or a quality level B point endpoint on a connection. Attribute, we will be talking about attributes. Utility segments are becoming more and more attributed, and that helps in determining and modeling the 3D utility models. And an attribute is considered a defined characteristic of a utility feature, and I will go out into attributes a little bit later. Deliverables change in this regard, that it is a sign and seal results, including a utility report that can contain metadata or other relevant data for inclusion in digital or paper formats. Depth, and I know our previous speaker, Compass Data Incorporated, you mentioned depth. There was a question about depth. This is the difference in elevation, obviously. I'm probably speaking to a lot of surveyors in the room. It is a difference in elevation between the top of the utility segment and a reference point that is anchored on a datum, such as a DTM, surface grade, absolute elevation, or benchmark elevation. Metadata was used also. That word came up a couple of times. It is all the data that is associated to describe context, content, and structure. Could be search limits, could be the records used, the dates of the delivery, the person signing the deliverable, any other documentation that revolves around the scope of work. I will touch a little bit about utility quality levels just to kind of freshen it up. I'm not going to go into detail about them. And obviously the utility report is a report or sufficient notes contained within a utility drawing, or signed and sealed by an engineer or a professional in charge, like a surveyor. And the utility segment is a continuous portion of a utility for which the utility quality level is consistent. The depths might change, but if you have a 12-inch ductile iron pipe water main running through the corridor of your project, and that size and material does not change, that is considered a utility segment, even though the depths might change. So that's something that is mentioned in the standards. As I mentioned, here are the quality level A's. Obviously, quality level A is the highest level of confidence with a visual verification. It is an XYZ. It can be tied to, it is tied to a utility segment or a subsurface utility feature to a project survey datum with an accuracy of 1/10 of a foot, which is 30 millimeters, and vertical, and 2/10 of a foot horizontal, 60 millimeters. Today we'll be talking about quality level B. We're going to focus on that. So I'm going to just go over that a little bit more in detail. A value assigned to a utility segment or subsurface utility feature whose existence and horizontal position is based upon geophysical methods combined with professional judgment, and whose location is tied to the project survey data. It is assigned to a utility segment, and I've mentioned what a utility segment is, when the following conditions are met. Utility segment was detected through the application of appropriate geophysical methods, which Eddie will be talking about shortly. And the geophysical signal was judged to be reliable. The interpreted position, this is where the professional judgment comes in. Interpreted position was judged based on knowledge and use of geophysical science, utility design, installation practices, records, visual features, and site conditions. And obviously it is tied horizontally. This is a horizontal, what we would consider designates. It needs to be tied to the project survey data with an accuracy of 2/10 horizontal. Level C, above ground features, connection. I'm not going to go into that too much. And obviously quality level D, standards, records, oral recollections, obvious visual clues such as pavement cuts, trenches, or existence of service. Some of the updates to the standards. A utility report contains information about the utility investigation that might otherwise not be conveyed. There's a recommendation in assisting the end user in understanding the subsurface utility landscape and risks. Provides recommendations to address those data deficiencies, if any. and complements the utility drawing deliverables with the appropriate notes that might not be included in the actual deliverable. Signing professional has direct responsible charge. There is an engineering analysis component. It does emphasize about the difference of one call versus QLB or QLC. It is not the same. How to differentiate the field markings. It also defines the precisions for the quality levels tied to the project survey datum. It talks about measuring subsurface vaults and manholes and also measuring depths. We had a tendency to call them electronic depths, but as Eddie will show, that is not truly the case. And our company, we have a very strong safety culture. This was the old way of finding utilities, and that is not the best practice approach at all. And I will let Eddie talk a little bit more about how we collect 3D SU data in the field.
Thank you, Radek. Can you hear me? Are you able to hear me, Radek?
We can hear you.
Okay, just making sure. All right, thank you, everyone. So my name is Eddie Gayton. I'm with WGI here out of the Chicago office. I have been in this business for about 25 years. I spent 6 years in the one-call industry before coming over to the SU industry. I do enjoy this side much better. Less stress. So anyways, I'm going to touch a little bit about the level B process as it relates to the 3D SU data collection. For those not familiar with the level B process, this is the process of utilizing geophysical methods and technologies to interpret the presence of subsurface utilities and marking their approximate horizontal positioning on the ground surface. I would also like to discuss the various SU tools of the trade commonly used for utility designation. There's really not one piece of equipment in the market that can detect all utilities. So having a diverse set of tools is key and will greatly improve your chances of a thorough SU investigation. Besides equipment, technique and operator experience are also key factors to a successful SU investigation. So because the depths are an important factor in creating a 3D model, it's important to understand how we collect this information from the various tools. And so, hold on one second. Some of the tools used in the trade, very common tools here are single and multi-frequency pipe and cable locators. These are very common in the SU industry, as well as in damage prevention. Ground penetrating radar is another tool that most firms use for the collection of, for the utility mapping process. And another tool that's very useful and used in this industry are SONs and duct routers. Some of these duct routers are also made detectable. So because the depths are important, I wanted to touch a little bit on how each one of these devices and technologies kind of work and calculate these electronic depths. And I'm going to start with the demonstration of how Gpr works. So here the Gpr is transmitting radio signals into the ground, and it's reflecting back signals as it goes over utilities or anomalies. In this case, we're looking at a 36-inch pipe. Gpr is applicable for all utility materials. Although GPR results in optimal conditions can be interpreted quickly with little training, extensive experience, and sophisticated interpretation skills may be required in complicated situations. Depth range of GPR survey is highly site specific and is limited by signal attenuation, which is dependent on the electrical conductivity of the subsurface materials. So for this illustration, we're calculating a depth of 6 feet. And if all the calibrations were done correctly prior to scanning, we can determine that estimated depth. And here we're looking at it 6 feet. Other measurements that we collect in the field are direct measurements, and these are done from quality level A test holes, access at manholes, vaults, valves. Any one of these are points where we can record these direct measurements to the top of the utility. For this next demonstration, I'm going to kind of just demonstrate how the pipe and cable locators work. Utilizing the transmitter, we transmit a electromagnetic signal onto the utility. In reality, we're actually detecting that electromagnetic signal, not necessarily the pipe. So in this case, it's emitting that signal and being collected up at the surface at the receiver. And for this demonstration, this depth is calculated or estimated at 7.5 feet. So 18 inches deeper than what the GPR had estimated. So it's important to understand that, especially in the processing of 3D modeling. I'll talk a little bit more about these pipe and cable locators. These tools have evolved over the years from simple single high frequency and analog displays to sophisticated multi-frequency units, which digital displays, and some of the key features utilized for 3D modeling is their abilities to calculate these approximate electronic depths. It's important to understand that depth accuracy can be affected by several factors though, such as interference from nearby conductors, which invite signal distortion and or bleed off. Soil conditions, poor utility installation methods, such as improper grounding, can also influence the accuracy of the electronic depth as well as distinguishing its horizontal positioning. With more and more utilities going into the ground, creating congestion, some manufacturers have been adding more enhancements to some of these tools, such as increased power, providing higher quality signal, enhancements to receiver software to filter out ground noise to provide a more accurate signal and less bleed off. And another cool enhancement is the ability to link the locator receiver with external GPS devices or receivers to enable mapping of the designated utility to GPS coordinates. And the other device I mentioned earlier is the sond and routers, the duct routers. These ducts and sond routers the sonds and duct routers are also common tools in the SU industry. The sond is a small device that emits a signal that can be designated at the ground surface. These devices are inserted into the accessible pipe or conduit that are typically of non-conductive material. These sonds are typically attached to a duct router and pushed into the target pipe or conduit. The routers themselves are also made to be detectable, which allows another option or method to trace the line out. So for this demonstration, the depth estimated here is at 9 feet. So understanding these different types of technologies and how electronic depths are derived from each is critical for the SU field data collection process, which is what I'm going to cover. Evolving 3D modeling is greatly influencing extensive SU field data collection more than what was collected in the past. Mobile application apps such as Arcgis Collector are becoming more popular in the field data collection as it is organized and effectively improves field to office workflow. ArcGIS is very user-friendly and customizable to any specific needs. Utilizing this cloud-based app, SUE field crews are able to electronically capture the data, collect the level B data as well as the level A data, and collect any data associated to those lines. Those lines or utility features. Some of the examples the data collected includes utility types, utility owners, sizes, depths, if obtainable, of course, utility structure, dimensions, and picture documentation. Since data is captured in real time, project managers like myself are able to access the data as soon as it's uploaded through, thus facilitating our analysis, our data management, and any other business needs. And again, this is a cloud-based technology, so it's very user-friendly. I think Compass Data mentioned this earlier. So some of these type of apps, we can enter this information live in the field while various crews are working on different parts of the project, and they're able to see the information being placed live, so we're not duplicating any information in the field. And again, some of the data that we're collecting are some utility features such as pedestals. We're collecting images, we're collecting dimensions and sizes that will assist our CAD production people. We're recording the electronic depths. Everything is being entered into this mobile app. And obviously the last part of the SUE data collection is the actual survey of the field markings, utility features, and the test holes. The data collected prior to this task is shared internally or with third-party survey consultants such as Compass Data prior to subsurface utility survey to ensure accuracy and quality control. So what we're producing from our app are these what we call utility inventories, where we're actually inventorying everything that was done in the field. We're providing the utility that was marked, the number of shots that need to be surveyed, the associated depths to those shots, how we calculated the depths, whether it's from pipe and cable locators, exposed at a test hole through quality level A, through a manhole, etc. We're also documenting obviously the owner and the sizes. And then we're providing all this information to our internally and to third-party consultants. Another cool feature that I didn't mention earlier was with the app has some project management tools, operational dashboards, allows us to visually summarize, see a summarization of the data. It's in real time, allows us to make quick decisions as things are happening live. Allows me to communicate more effectively with our field crews, and also gives us some options on multi-format deliverables for our clients if so requested. So with that, I would like to pass this back to Radek, who will continue with the processing of the SUE quality level B data for 3D modeling. I'd like to thank everyone. And Radek, I'm going to pass this back to you.
Perfect. Thank you so much. I'm going to share my screen right away. A little bit about what Eddie mentioned for the actual processing of the quality level B data. Depending on what geophysical detection methods were used, whether it was multi-channel GPR, PCLs, sound, or radar, it is important to note that and have that as an attribute for your utility segment, because it will determine how the data gets processed and how the utility depths get normalized per the standards. two different methods I think Eddie mentioned was recording it in descriptor or shot sheets, otherwise known as utility inventories, and then recorded in raw data where you actually record it on an iPad or the actual PCL or a Gpr unit itself. Utility depth normalizing, the depths, depending on, I liked Eddie's graphic, depending on what method you use, obviously it's just a little bit basic math, but it is important when you're dealing with larger types of utilities where the difference between a 48-inch pipe might be 2 feet, whether you're measuring it to the center based on a pipe locator or a GPR to the top. So that's a significant difference. And obviously, to get the to get the top of utility elevation using GPR, we're just subtracting the depth to the top of the pipe. To get the electromagnetic depth, the top of the utility elevation through a pipe locator, you subtract the electromagnetic depth and half the size of the utility to get you to that center of the utility. This is critical. This is we've been doing pseudo electronic depths for a while. Without really, hopefully, now we're getting a better understanding of why the methods of the detection, of the geophysical detection, are so important. And the last that Eddie mentioned was the sonde depth, which runs usually at the bottom of the inside of the utility facility, and that is the ground elevation minus the sonde depth plus the size of the utility. And what happens once we get those depths? Because now we want to model this. Now we have the data. The data, post QC, we've checked everything. We have attributes. Now we have to assign these attributes to utility segments. Some of them can be done in the field, like Eddie mentioned, in an iPad or even an iPhone. We have applications to do that. Some can be done during the survey portion of the utility location. And then there's parts like the depth calculations that are done post-processing in the office. What is a utility segment? I'm going to remind everyone, I think I mentioned it earlier, but it is a continuous portion of a utility for which the utility quality level is constant, and that is critical. Because anytime you have a change in quality level or size and material, that is no longer the same utility segment. So that is very specific in the standards. Other than the depth, everything is the same as far as the attributes. And some of the attributes, I mentioned in the definition, it's a defined characteristic of a utility feature or a utility segment or a singular point on a utility feature or segment. Some of the attributes can be utility type, size and shape, encasement, configuration of non-encased multi-conduit systems, like duct banks. We have, down here in Florida, AT&T duct banks can be up to 24 4-inch PVCs in a 12 or 3x4 configuration. Age and date of installation, condition, material types, and obviously depth. Once we actually get to the processing, this is an example of utility segment attributes that we have. We already have a pipe here modeled. I'm going to highlight it real quick with a highlighter. We have this portion modeled, and that segment attributes, utility segment attributes, only pertains to this portion of the pipe, and that is critical to mention. Obviously, quality level B, method of obtaining the depth, which is, in this case, with GPR, so we know that we're subtracting only from the ground elevation the actual depth. The beginning elevation of the segment and the ending elevation of the segment, those might change. And in this case, we have material size and owner. Date of install can be used also. And any other attributes and metadata that we can use. there's some challenges working with 3D data. And those challenges can be twofold. I look doing different datums. We know for a fact that if you're using a different datum, there's no way that your data is going to be correct. Some aberrations in modeling might occur, where you can have kinks in the actual lines. Those you have to isolate. That also has to go through a QC process. And some of the egregious ones are actual conflicts that are based on depths that we gather from the field. And at that point, supplementing with quality level A test holes is highly recommended. Obviously, we can't have a gas main going through an AT&T duct as shown on this example. Some of the 3D SUE deliverables and deliverables per the standards. Once again, sealed results, a utility report, utility drawings, utility data for inclusion, either digital or paper format. 3D models databases can be also a GIS database. Obviously, any metadata associated with the deliverable. Some of the SUE benefits, and the benefits are tremendous. I've already talked about the cost-saving benefit, but we also have a clash detection analysis, which is a conflict analysis. Quality level test hole is recommended at that point. We have the cost savings. I already mentioned that. From a construction standpoint, we have limited construction delays, fewer redesign issues, going back to the engineer of record, getting redesigns and RFIs. Utility damage avoidance, that is a big point. I know the Colorado Senate passed 2 years ago, I believe, the 811 law. And for us, public safety, we're saving money, yes, but public safety is one of the main components of using SUE and utilizing SUE in your construction, in your work, in your design. As you might know, we've had in Fort Lauderdale a couple of instances, I think several instances of force main and water main hits that could have been avoided, shut down the city for half a day. I think the water main shut it down for a week. They had a boil water order. So public safety should be at the top of the list. I saved the best for last. And that will conclude our presentation. Thank you very much for joining us.
Yeah, Radek and Eddie, thank you very much. Very detailed. It's great to see the whole process, and I'm glad that you related this to the standard levels. And speaking of that, had some questions about the SUA, well, the ASCE standards. The question from earlier today that we didn't have time for was, it's the ASCE 38-02, which is 2002. Do you know if there's been movements or updates since then, or supplemental publications?
Yes, so actually there's going to be an update in 2020. It's 3820, and there's a draft copy out there. It's probably going to be, it was supposed to be ratified this year because of the situation with the pandemic. I think things got a little bit delayed, but I understand the ratification was supposed to happen this year for the 38-20 standards updated.
Cool. Are there any, do you know of any highlights that might be included in it?
And that our presentation basically highlighted some of the changes. So the utility reports, the sign and seal we've already talked about. The utility segments, utility features, a special emphasis on the depths that Eddie mentioned and I talked about. Those are some of the main components of the changes.
Okay, that's great. And I noticed around the world, many countries have adopted essentially the ASCE standards, or at least the levels and a lot of that. You know, Malaysia's is almost word for word. Well, this is great. Somebody had asked me yesterday about this. You know, GPR. There's a lot of fuzziness, no pun intended, about the images, but the about the capabilities and best practices. So I've been reading up Europe. There's the European GPR Association, and they put out guidelines. It's been very helpful. Do you know if there's anything here in North America like that focused at GPR?
I'm gonna let Eddie handle that question, but I will say that one of the things that I emphasize to my clients and our clients as a project manager and a production manager is relying on GPR only is not the way to go. You have, like Eddie said, different tools in the SUE toolbox that need to be fully utilized to be able to achieve a high confidence level of utility locating. I just read an article about, I think in Italy, they found the underground water ducts in the city. Super interesting read. And once again, that's great for finding architectural, old architecture, old remnants. Same thing like with the Viking ship up in Norway. That was a fascinating read. They found a Viking ship outside of the church on a hilltop. And once again, that's more of a fun type of locating. There is no damage, there's no concern, there's no safety issues involved with that. But I'll let Eddie handle that one. Eddie?
Yeah, like Radek said, you know, utilizing GPR as a standalone is not the best option. I mean, it is a tool that we use. It's available to all our crews. Here in Chicago, I usually tell our clients it's a 50-50 chance. And I know, you know, there's certain areas in Chicago where I know that this equipment's it's gonna work great just from past experience. And then there's just other areas where we're not seeing anything. And so unfortunately it's, you know, it's a good tool when it works and it's great. But it's as a standalone, it's just not recommended. As far as organizations or publications that are out there or, you know, related to GPR, I don't get too involved in that. I know that there are a couple groups out there, a couple groups on LinkedIn. That's a great resource for trying to learn the GPR technologies and what's involved. I can't think of some right now, but there are plenty of groups out there. But that's one of the best places to find those groups. And they normally do share a lot of content and information, which is very useful in our world.
And I would just like to add, am I muted? No. I would like to add that for those of you that, you know, GPR does not find pipes or structures. It finds aberrations in the soil condition and density and disruption of the soil. So the denser the soil, the harder, if there's like here in Florida, we struggle continuously with the water table because we go 3-4 feet deep, you know, especially along the coastlines, and we're already hitting that water table. So GPR is not that effective. Saltwater, clay conditions up in the middle of Florida, we have issues with GPR. So caution should be used. When people ask me, can I get GPR here? I say, we'll do SUE for you.
Yeah, well, I've found the limitations the hard way. Parts of town with clay, no good. When it's really wet, and it's really wet here a lot, that's a difficulty, but it has its place. A question from Brant at Compass. He said, what states and localities are taking the lead in requiring SUE for utility mapping?
So I can down here for Florida, all the DOTs in Florida basically implement SUE. It is a tab part of the staff hour estimate and procurement method. It is a standalone tab for locating utilities. So the DOTs here, local municipalities, private sector a little bit harder. Developers don't want to pay that kind of money just yet, but we're chipping away at them. So Eddie, you want to talk about a little bit up north?
Yeah, I mean, Illinois, they've been implementing SUE here in the state for since 2001. I think they've had two providers since then, up to this point still. The main districts up in this area are really the Chicagoland area that utilize this, and the southern portions of the state as well. Minnesota's another one that has implemented SUE for many years. And, you know, those are the two main states that I mean, I've worked in other states, but those are the two main states that I know have promoted and implemented SUE for many, many years. And so that's all I could speak of about as far as up here.
Okay. So Eddie, advice that I'd gotten through an ASCE presentation years ago was work backwards on the levels for the methodology. You know, start with the filed records, you know, level D, then go to the surface features appurtenances, level C, then go to what geophysical methods you can in B. And if you narrow it down to a point where you've got to excavate, and then maybe you could get a physical shot on something. Is that pretty much, it looked like that was your process.
That is the process. All of our level B work, well, I'm gonna say with our level B work, we definitely utilize the level D and level C processes prior to even getting out on the field.
Okay.
The minute that I have a project, we immediately start collecting internally the utility records from the utility companies. Here in Illinois, we have a process called the design stage that's being implemented by the one call system here. And basically you just call and you put out a design stage ticket for the area that you're going to work in, and they give you contacts for those utility companies, and then we just go ahead and reach out to those utility companies. So before our field staff even gets on any of our projects, they usually have about 75% of those utility records, which is key because, I mean, trying to do this work blind is very tough. But those are just guides. You know, they're nothing but guides. Our experience, our equipment, our processes is really what's key here. And we just utilize these other tools collected from the level D and the level C to help us with our final deliverables. But we do implement all of those, especially at the level A part, because there we are implementing just about all of them, all those levels.
Okay, we got about a minute for one final question here. Are there any liability issues with the possibility of damaging existing utilities using sondes and duct routers, or are they only used in spare conduits, for instance?
Yeah, they're mainly used in spare conduits. We don't encourage anybody to utilize those for conduits that have cables in them or any other facility. The liability is there for us to potentially damage that utility, and we definitely don't want to do that. So
I do want to jump in here, Eddie.
Yep.
We did have an instance in actually down here on a crossing, Arcgis crossing for a water main for the city of Pompano, I believe, and it was a bridge expansion. They were widening the bridge and they could not locate the water main. So we actually received permission to cut into the water pipe to shut down the water. We ran the sonde through the actual pipe, and we're able to locate it both vertically and horizontally like that. So there are exceptions, I would assume, but yeah, for the most part, Eddie has it right on the point.
Right on. Eddie, Radek, thank you very much. Very comprehensive. You actually answered a lot of the questions that popped up during your presentation. So thank you so much.